Okay. Let's go to BSA for just a moment. I'm going to change this from an ONS route to BSA router. And let's say a CIX or BSA rover. So if I load that, now, for a dado command, what we have, and those of you who have BSA will understand what I'm saying here. Those of you who don't, just hold on for just a minute, okay? But what we have in BSA, we have a ton of parameters that are sent to BSA, and three of those parameters have to do with tool speeds. And this one right here, DSP, RSP, and WSP. That's the work speed, the rotational speed of the spindle, and the depth speed. That's what these letters are referring to. We don't refer to them as that. We refer to them as spindle speed. That's the rotational speed. Work speed is our feed rate. And DSP is the depth speed. We call that plunge rate. Now, if these values are 0, then BSA BSA Works or B Solid will utilize their internal speeds that you've set up in BSA Works or B Solid. If those are not 0, then it uses the ones that you send to it via these variables, which means that if you go to the tool library and you have a feed rate that you've defined, then BSA B Solid or BSA Works will utilize those three speeds. If any of these speeds are equal to 0, then it will not. It will ignore that 0, and that 0 is basically telling B Solid or BSA Works to use its internal speeds that have already been set up within that program. So if any of you have questions on that, let me know later on and I'll clarify it, but otherwise we'll proceed from here. And I'm going to get something other than, well, we'll just leave BSA in there. It's no big deal. Now, for every tool, this is a really, really important concept that not a whole lot of people really think about or maybe even know. But you can have the same actual tool. Let me give a really good example. This 1/4 inch down shear. Let's say you have a 1/4 inch down shear. Oh, this is BSA, doggone it. Excuse me, I'm going to have to change this to a different post processor. And the reason is because BSA does not have tool change numbers. It accesses a particular tool by its name, but most don't do that. Most routers don't. So let's pick up, how about a shop saver? Because a shop saver picks up tool from a tool number. So if we go to the tool library now with a shop saver in there, now we have a tool number that we have to assign. Now, what I was going to say a minute ago is that if we have a particular tool, notice we have 10 tools all together in here. And let's say we have a 1/4 inch down shear in tool position number 3. And here's the diameter of that tool. And here are the various speeds. But what if you have that same tool, you want to use that exact same tool, and you want it to be you want that tool to have a different speed rate for whatever reason. Well, you can actually copy this into the 11th tool, give it the same tool number position, but just change the tool rates and change the name. And then when you access that 1/4 inch down shear number 2, for example, when you access that particular tool name in the making of a machining operation, all of the feed rates for that second tool name will come into play. For example, let's make another tool right here. Number 11, I'm going to call that 1/4 inch, whatever I said, down shear. And I'm going to call it slow. Because maybe I'm using this to cut out lumber. And so we want the spindle speed to be fast, but we don't want the lineal speed, the feed rate, to be very fast. So I'm going to cancel this. So the tool changer position is still number 3. Tool diameter is the same. Percent step over is the same. And this feed rate, however, we want to be 100, whatever that is. It's just less than what we had before. Plunge rate, we can have that to be the same. And the spindle rate, maybe we want that to be 24,000 RPMs. If the machine can handle it, of course. But the point is that we have the same tool in the same tool position, tool changer position, but we've changed the feed rate to be slower because we're going to use lumber to make crown molding, for example. Well, you want the feed rate to be slower, but the spindle speed to be really fast so you don't burn the material. And now, when you go into the CNC machining library, and here's a down shear like normal, like we had before. However, we have an 11th tool, which is the exact same tool as this 1/4 inch down shear, but it's got different speeds associated with it. So you can do that as well. Now, the really, really convenient feature that we have in this tool library, and one that makes it so that you don't burn material and you don't forget to change things, is this little checkbox right here. Apply material adjustment from the inventory. And you have that 3 different times for each of these rates. Now, by the way, technically, each of these should be either speed or rate, because speed is a scalar quantity, not a vector. A vector, remember, is a combination of speed and direction. But a speed is like 65 miles an hour is just 65 miles an hour straight. I mean, in whatever direction. That's called a scalar quantity. 65 miles an hour going north is now a vector because you have speed with direction. Velocity is a vector because we have speed and direction there also. At any rate, speed by itself, and that's the difference, by the way, between speed and velocity. One's a vector, one's a scalar quantity. At any rate, all 3 of these should be named either speed, speed, and speed, or rate, rate, and rate. But the reason they're not is because of this industry. The industry, if you call it the feed speed, people would look at you like you're crazy, or the plunge speed, or the spindle rate. Nobody calls it that. So even though they are synonymous, it bothers me to have all 3 of these not the same, because they are the same concept in physics. However, they're different here because our industry just calls them different names. One is rate. Everybody knows what a feed rate is, but nobody knows what a feed speed is, even though they're identical. Getting back to the subject on hand here, if we apply material, if we check this box, then some interesting things happen. That speed for this particular tool, and by the way, that's another reason for having two tools, like I just did a little bit ago, being named the same thing. We have tool number 1, or this tool number 3 is a 1/4 inch down shear in position number 3, and it does not have any of these boxes checked. But on another one, the one that we added, down shear, what was it called, slow, we might want to check these because things happen quite a bit differently. And what is that? What do I mean by that? If we have one of these checked, notice the feed rate only is checked. It's 210 whatever. And we're telling it to apply the material adjustment from inventory for this tool. What the heck does that mean? I can go to the material library from right here, by the way, edit material. The whole reason this button exists here is so that you can adjust the material inventory accordingly while you're adjusting this adjustment or this application of an adjustment. If I go to the material inventory, that's panel number inventory only. And if I choose one of these, let's say this one, birch ply, 1/4 inch birch ply. That's a really good example. And I'll show you why. If I click edit, over here, I'm going to tell it that on the feed rate, 1/4 inch birch ply, I can move through that. You know, it doesn't have to be a slow feed rate. I can cut through that really fast. So I'm going to say, I want to speed up, whatever the rate is, I want to speed it up 100 by 20%. If you want to speed it up, then it's 100 by 20%, then it's 120. If I want to slow it down by 20%, then I will put 80 here, because that's the percent of the default feed rate. So if I want to slow it down by 20%, it's going to multiply the feed rate by 80%, the 210 that you saw earlier. If I put 120 in here, it's going to multiply the default speed rate by 120%. So it's going to go faster. I can have every one of these filled in. Let's say I want to go faster, and the feed rate, or excuse me, the plunge rate, I want that to be, I want that to go faster also. 1/4 inch material, I don't have to go slowly through it. I can go through that really fast. So let's change that by 130%. That's how fast I want that to go through. And the spindle rate. Do I want the spindle rate to speed up or slow down? Maybe not. Maybe I want it to slow down, who knows? But if I leave that at 0 or blank, if I put a 0 in there, it's just like it's blank and it's ignored. Now, watch what happens. Remember, feed rate, I have 120%, plunge rate, 130, and spindle speed is not going to be changed. If I hit the OK button here, birch ply is now saved. I hit OK again, we're back into the tool library. If I check this button, or that, what is that, a box? If I check that box, now, if there is a number in that material, it's automatically going to apply it to this 210, or whatever that happens to be, whatever it is set up on your machine. So if it's not checked, it's not going to do that at all. It's going to, if this is not checked, then those percentages that I put on the material itself, that 1/4 inch birch, is going to be ignored. It's not even going to, it'll be, this feed rate will always be 210 no matter what. If I put a check here, a check there, and maybe even a check here, then whatever material I use, it's going to check to see if that material has a speed up or slow down for the CNC. As an example, let's go back to the material. As another example, let's go back to the material and choose something else, like 1.25 inch, 1.5 inch MDF. Now that's some thick stuff. 1.5 inch MDF would be very difficult to plow through. And we might want to slow things down quite a bit. So if I edit that, now that's, remember, this is MDF, very dense material. That's the D, that's the number of the D here. The feed rate, I might want that to slow down by maybe 50%. And the default plunge rate, maybe by, I don't know, maybe 70%. Spindle speed, we might want to speed that up by maybe 110, or by, we're going to, if I put 110% in there, that means it's speeding up by 10%. This is slowing it down by 30%. This is slowing it down by 50%. Now, if I ever use that material, see, the beauty of putting this here is that once you put this material, these factors, these speed up and slow down factors in the inventory, you don't have to worry about it anymore, because whenever you use that material, everything will automatically adjust, no matter what tool you're using, if you do this for all your tools. I would suggest doing this for all your tools, unless there's a special reason why you would not want to do that. And those special reasons, of course, always come up. But now, when you're using that particular tool whose default value is 210 on the feed rate, when this material is used, that 210 is going to be converted to 105. That's how fast the feed rate is going to go. So it's going to go a heck of a lot slower. And when we use 1/4 inch, what do we have, birch ply? When we use 1/4 inch birch ply, where is it? 1/4 inch birch ply, if I edit that, that's going to speed up. The same tool is not going to go at 210%, but, excuse me, not 210, whatever it is, feet per second, meters per second, or meters per minute, or whatever. It's not going to go at 210. It's going to go at 120% of that. So 20%, 120% of 210, what is that? 42 plus 210 is 52, 252 feet per second, for example. The point is that for each material, your speeds, your plunge rates, your spindle speed, your feed rates can all change that according to what's appropriate for that particular material, without you having to worry about it. And so you'll put one material on there and run it, and automatically your router is going slower in different areas, or it's going faster in different areas. Now, in order to have a check to make sure that you don't mess things up, no offense or anything, of course you'd never mess anything up, but just to make sure that you don't, if you go to the machine setup and post processor screen, you'll see that there's a horizontal rapid move rate of 3000, or whatever number you have in your settings. Kevin Pro will not allow your settings, your percentage increase, to go faster than that. And your Z value is not going to go faster than that, because those are your rapid move speeds that you've already determined, theoretically, hopefully, that are maximum for your router. And so if you were to put down, instead of 120% like I did, if you were to put down 530%, because you want that thing to really fly, and if 530% times your default speed was faster than 3,000 or 400, depending on which speed it was, the program wouldn't allow it. Now, spindle rate is different. Spindle rate, you can make that anything you want because your router, unless it is an extremely cheap router, the majority of routers, the great majority of routers have internal checks that won't allow your spindle speed to go over its maximum value. So we don't have to worry about that one. And if you have a really super cheap router, you should be using it anyway. And when I say cheap router, I'm not talking about Shop Saver. That's a great router. And most of the routers we have in here are all excellent routers. Okay, any questions on tool speeds or adjusting tool speeds and how they are dependent upon material? Now, right here on the right-hand side, and this is of each tool. Of each tool, you have a maximum depth of cut in one pass, because some tools are so tiny that you don't want it to go through 3/4 inches of MDF, because that would just break it, or eventually it would break it. And so you might want to tell the program that with some of your tools, you only want to go in 1/4 inch at a time. So if I were to put 1/4 inch here, 0.25, if I were to put 1/4 inch here, and by the way, I'm using inches because we're in inch mode. But if I were to put 1/4 inch there, and let's say you had to go through 3/4 inches of MDF. Well, it would do that. It would perform that drilling 3 times. It'd go down 3/4 inch. It'd come all the way up to safe height, and then go back down to 1/2 inch, and then come all the way back up to safe height, and then go down 3/4 inch. So sometimes I had one individual who put this in millimeters, and he thought he was in inches, so I put this in as 1. And what that's telling the program is you go down 1 millimeter at a time. So if you have a 3/4 inch material, which is what, 19 millimeters, and that's going to go down at least 19 times to drill that 1 hole, all the way up to safe height, down. Pretty soon your Z bearing's gone. Excuse me. So when you enter these numbers, make sure what unit you're in. Now, if you say 1 inch is the maximum depth of cut, that doesn't mean it's going to go in 1 inch. I could put 10 inches in there. Excuse me. I could put 10 inches in there, and it does not mean it's going to go down 10 inches. That means that's the maximum that's going to go down. Now, in all cases, whether you're here or you're making a drilling operation or a dado cut, and you tell a program, let's say you're making a drilling operation, that's the most common, or a profile cut where you're going all the way around the material. But let's concentrate on a drilling operation for a moment. If you're making a drilling operation in Cabin Pro, and you tell it that you want the depth of cut to be 2 inches, all you're telling the machine, the program, is to cut whatever material you've got, cut through the entire thing, and then go into your defined amount into the sacrificial board. So let's get out of here for just a moment. Go back into machine setup. And for your machine, we're telling the program that the maximum depth allowed into the sacrificial board is 0.007 inches. That's just a little tiny bit. If you are, remember that 0.007 inches. If we go into the machine library and we have a drilling operation, here's it, well, somewhere. Where's the drilling operation? Oh, here's drilling operation. Now notice we have a depth of cut of 1/4 of an inch because we want these to be going down a 1/4 of an inch. If I were to put 2 inches there, what I'm telling the program is find out what the thickness of that material is, go through that thickness, and then go an additional 0.007, that maximum amount, the maximum depth of cut allowed into the sacrificial board. So just because you put 2 inches in there doesn't mean it's going to go in 2 inches. It will never, the program will never, ever, and this is a categorically correct and absolute statement, the program will never go in deeper than the thickness of the material plus the maximum depth allowed into the sacrificial board. Well, I shouldn't say that. There is under one condition it can do that, and that is if you have a panel that you define in Kevin Pro, that's say 3/4 inch MDF or a melamine, and you make a really dumb mistake and put a 1/4 inch material in there instead. Now, the program thinks that you've got 3/4 inches that you're going through. And it's going to go through that 1/4 inch material 3/4 of an inch, which can be a very expensive error. Which is one reason why in the CNC options, which we're also going to be covering, this is a nice little introduction into it, why we tell a program, why it's a good idea to give as part of the name the material thickness and material name. That's the whole reason why this is here. Because one time we did have somebody, before this came about, we had somebody who put the wrong material down. Instead of 3/4 inch material, he put down 1/4 inch material. Had a $6,000 bill because his spindle, he had a Como router, and went straight into his sacrificial into the machine itself. Excuse me, the steel plate under the sacrificial board, and that was misery. So we added this so that's almost an impossibility. So if you have your names of materials, your names of your CNC files, including the material thickness and the material name, it's really kind of hard to make an error. Now, I'm not going to say you still can't because it's still a possibility, but if you do, you should slap yourself. Okay, let's go back into the tool library and see if we've covered everything here. The maximum depth allowed in the sacrificial board. Now, this one right here is interesting because notice down here in parentheses, it says not to exceed 0.007 inches as defined at the machine setup screen. So that's a safeguard. Just as we have some safeguards for maximum tool feed rates and plunge rates and speed rates, or at least feed rates and plunge rates can't go faster than what's set up in the machine library, the machine setup screen. So too, do we not allow your tool to go deeper than what is defined in the machine setup. So I could put 0.005 here if I wanted, but if I said put 0.008 there, that's deeper than that 0.007 that is defined at the material setup screen and won't allow it. And I'm not sure if it'll give you an error message or just say, sorry, Charlie, we're going to use 0.007, one of the two. Oh, it didn't allow it. You see what happened? If I put 0.008 and I go to a different tool, it's going to save that. But when I come back to it, it didn't save it as 0.008. It said, sorry, Charlie, it's going to be as per setup with no message. Now, if I put 0.005 or 6, and then I hit next, and I come back, now it's 0.006. Sometimes we might get a tech support question that says, you know what, I put 0.008 in there and the program won't save it. And then I gotta say, read what it says right underneath. Oh, sorry. But again, you can put a number less than that in there all you want. Less than what is defined at your machine setup screen. Now, that does not mean that your setup screen is correct. All it means is that we're going to assume that what you've put here is correct. And if it's not, you need to call the machine company, in this case, Shop Saver, or look at your manual to see what values should be put here. But these values are strictly for the machine itself. Now, there's been a major change on the program. I may as well tell you this now. It's on the update notes, but if you go into the profile cut, which is right up here, this no longer, oh, notice that says 0.75. It used to say ramp cut lead-in distance. This is important enough for me to show you this because you'll see why in a minute. So I'm going to go to, that's version 6.6. I'm going to go to Internet, Program Update. I'm going to download the update. And this is important enough to show you to download this update and take the time in doing this. So we're going to download. And we're going to keep it. We're going to open when done. We got about 5 seconds before it finishes. And okay, opening momentarily. Okay, more information, more info, run anyway. And now the update is being installed. Now, remember, that used to be for years, ever since we've had the CNC version, since the 90s, that has always been distance of the ramp, of the horizontal leg of that triangle that's formed with the ramping of the tool into the material. That's been changed drastically, and you don't have to change this on your router, but you may indeed want to, because what we've done on when you install this update, if you haven't changed it, if it's anything less than 20 degrees or greater than 80 degrees, the program will automatically make it 45 degrees. So we've changed it from an actual distance to an angle. And here's why. Well, let me show you what would happen now. Remember it said 0.75 earlier? If I go back into Cabin Pro, where is it? Excuse me. If I go back into Cabin Pro, we're now at version 6.7. And it's putting the post processes in. And the support files, now we're done. If I go back in that exact same spot into the CNC machining library, what you'll see now is a ramp cut lead-in angle. Now, this says 0 degrees. If it's 0, it means there's no ramp. It's going straight down. If I put 0.75 in there, and it'll just send it back to 0. However, if you put your cursor over this, the arrow, it'll show you what the acceptable values are. So if we put 45 degrees in and save that, it will now either climb or go in a clockwise direction or a counterclockwise direction at an angle of 45 degrees. The reason this was done is because now if you have a 3/4 inch material, it's going to go in 3/4 of an inch on the horizontal leg, because that's 45 degrees in this particular case. If you have 1/4 inch material, the ramp lead-in distance is going to be 1/4 of an inch because it's 1/4 inch thick and 1/4 inch in the other direction, unless of course you have a different angle in there. Oh, wait a minute. Let me take that again and change it to 45 degrees. And this area of Cabin Pro is very, very unforgiving, and you have to hit apply, otherwise nothing's going to happen. So if I hit, otherwise that would not have saved. If I go back and look at it now, it will save, but you have to hit apply because, this, like I said, this is the only area of Cabin Pro that is very, very unforgiving when it comes to having to click the apply button and not saving things automatically. Any questions so far? Before we go into the general settings. Okay, Valerie, how much time do we have?
Sorry.
Valerie?
10 minutes.
Okay.
I couldn't find the unmute button for a second.
Oh, okay. General CNC options. I think the main area here is through preferences. This area right here, after processing the CNC code, what do you want to look at? Now, if you have a G-code oriented router and you want an external CNC simulator, we use Techno's simulator that they've given us permission to use. And it's a pretty good little simulator. If we want the internal CNC simulator made by Cabin Pro, that's a pretty good one as well, because it will show you it'll show you how the machining is going to occur, and it shows you that machining from the actual G code that's produced. It's not it's the actual G code as if it's your machine. Now, formatting the numerical output. If you're dealing with inches, number of digits is suggested to be 4 digits past the decimal. If you're dealing with millimeters, this automatically changes to 1, but you can change it manually to something else if you want, including 0. That's not one area past the decimal is a good idea generally, and 4 maybe 5 past the decimal if you're using inches. Now, I'm not even going to mention general CNC code and user-defined units. We have one person in the entire world that uses that, and it's not worth discussing. Pocket and dowel placement. We're going to skip that today also. We might want to do this again next time, but we're running out of time. And the main area that I wanted to talk about today are 2 areas: profile cut options and small parts. So even though the rest of those deserve discussion also, let's go to profile cut options and small parts. Profile cut options first. Usually, if it's available, it's suggested that you use along the bottom, left, top, or right side, one of the areas down here. And actually, this is going to be changed today because this is an error. See where it says corner 1, 2, 3, and 4? Well, that is exactly the same as these four. Those are being reproduced. So these are going to be deleted. These are going to remain, but maybe tomorrow, if you look at this tomorrow after downloading an update, which will be on there probably tomorrow morning, what you'll want to do, what I would suggest doing, if it's available, is along the bottom side. Some do not allow along the bottom side, like BSA is a perfect example. They insist on working in a corner 1, 2, 3, or 4, which is why those others 4 are up there. But here, I like this one much better because what the program does on these last 4 is it goes in at the angle that you select on the screen that we were on a little while ago. Remember I put 45 degrees in there? The ramping angle, it'll go in at that angle, and then it'll cut the part itself out, and then it'll go past where it came in the first place and then come out. What it does on these corners instead is it goes in at the angle, comes back and plows out the area that it came in on, that's equal to the tangent of that angle, and then it goes all the way around. So it's using, it goes in, back, and all the way around. This one is cleaner when it goes in along the side, because now it just goes in, around, out. But of course, it's whatever preference you have. Plunging options. Do not use a ramping plunge on the second pass if existing when cutting out parts. Usually, you want to put a checkbox in there, a check in that box. And the reason is, on the second pass, some people, and one individual in particular, has a router that I dislike, and it could only go in about ½ an inch at a time. So, no, about ¼ of an inch at a time, excuse me. He's got a really tiny spindle, and it can only go in ¼ inch at a time. So what he does is he makes a second, your onion skin, normally it's like a 32nd of an inch or 1/16 of an inch maybe. His is ½ an inch, sometimes maybe ¼ of an inch. So in his case, he does want a ramping plunge on the second pass because you're going in on a ½ inch material. But if your onion skin is normal, like 1/16 of an inch or 32nd of an inch, and then you want to put a check in that box so that you don't use a ramping plunge, because you just go straight down and cut it out, because it doesn't take much to go through 32nd of an inch. But if your onion skin is ½ an inch or ¼ an inch, you may want to take that check out. Now, feed rate options. You can enter the feed rate used for the first pass if it should be set here rather than at the tool library. Now, this also will go to BSA. If you're using BSA Works or B-Solid, and if that's 0, it's ignored. But there are some people who want to set a global feed rate for the first pass all the time, and a global feed rate that should be used for the second pass all the time. Now, this one's more commonly done than this one. This one is usually set to 0 because your feed rates for each tool is usually going to be different. So that's usually not dealt with. That's usually a 0, but it's there if you need it. This one, on the other hand, it's nice to have a feed rate that cuts out second passes, like a thin onion skin or tab, so you don't have to deal with it on your so it goes faster on your cutout. If you have a 0 here, then let's go back to the tools section. If you have a 0 there, then your feed rate will be 1100 or whatever it happens to be. If it's going to be adjusted by the material, it's going to be that. But your feed rate will be the same when cutting out the first pass and the second pass. And many times it's just not necessary for the second pass. You can remove on the second pass. So if you want to really have it go fast on the second pass and override your tool feed rate, then you put a number here. And again, that feed rate cannot exceed what you have set at the machine library. Point-to-point routers and single part files. This is a fascinating, those two checkboxes are absolutely incredible for based upon what you're doing. There are some people who want the initial length and width to be cut out and to be squared off. If, let's say, for example, you're making single parts. You have a nested machine, but you're making single parts also. And so there's a part at the opening screen of the program. Let me show you. At the opening screen of the program, reports, you can either have nested CNC or single part CNC files. The single part CNC files will make your CNC machining for every single part in that job. On top of it, it will define each of those parts, or excuse me, each of those files according to what you have set here, options for point-to-point and or single part files. Normally, you want the cabinet number and the part name. Maybe the room number, maybe not. But at least part name and the cabinet number. You don't need the material. Who cares about that? Because as long as you know what the name is, or maybe you do want it, but it's there if you want. So let's assume for a moment that you have a nested machine, and you've cut out a number of parts on your nested machine for a particular job. And then you realize that somebody with a forklift runs over a shelf for cabinet number 8. Well, that's when you can go into the area and pick up a file for cabinet number 8, shelf, adjustable shelf, as an example. This comes into play here. Do you want to set that a scrap piece of material or a full panel or whatever, one that at least is as big as the part that you're about to cut out, in the corner of your router? And do you want the initial length and width to be, do you want that to be a little bit bigger by these parameters that exist in each part at the optimizer setup? The optimizer setup, remember, it tells you how far from the edge of the panel you want to start optimizing. Usually that's about a 1/16 of an inch or a 1/4 of an inch or something like that, probably about a 1/4 of an inch. Well, if you check this box right here, then what'll happen is that if you have a 20 by 30 piece material, part rather, the material of that part is 30 inches by, or 20 inches by 30 inches. It'll add a 1/4 of an inch to it, and it'll first cut off that 1/4 of an inch so that the whole part is squared off, and then it will machine that part according to whatever is appropriate. If you have this unchecked, then that won't happen. What'll happen is that you put that material in, and it'll just cut out the part as its original dimensions, period. And the reason we have that is for horizontal boring, because horizontal boring, you want that to exist. But you have those choices. The profile cut when using a point-to-point, this is similar to that, because do you want to cut out the part first and square off the edges? Or are those edges already going to be squared off? And because you cut them on a panel saw maybe, and you don't need them to be squared because they're already squared. But you'll have to experiment with those two to see which ones will affect you the most. Finally, small parts. I encourage you to look at this and really think about these a lot. Here's, I want to go through this, and then we'll end. Enter the size of part under which it will be cut out slower than usual. So you can tell it that if you say 0 square feet, then it's just going to be ignored. But if you put a square foot in there, for example, then a part that is a square foot in area will be cut out slower. And how much slower? Whatever we say here. Now notice we don't have an actual number until we get to the very bottom. So we could say, don't adjust the speed at which the parts are cut out. I was just kidding. Or just don't have that in there at all. If you have that chosen, do not adjust the speed at which parts are cut out, then nothing is going to happen. If you say reduce speed by 30%, then whatever the feed rate is going to turn out to be, it will be reduced by an additional 30%. If, on the other hand, you tell it, just reduce it to a speed that I'm going to put in. Reduce tool speed to the one that's specified right here, and now you put in an actual rate, whatever it is. So that's for smaller parts so that they are actually cut out slower than normal. Now, what do we want to apply it to? Do we want to apply it to the first pass? Usually the answer to that is no. And usually this is not checked at all. And the reason is because your vacuum is still going to hold down that part because of you're not cutting out the skin yet. But when you're cutting out the skin, you may very well want to reduce the rate at which that thing is being cut out so that it doesn't get thrown across the room, because the vacuum is going to be altered at that point. So usually this one is left unchecked, and sometimes this may or may not be checked based upon what you want to do with it. Cutting out parts based upon part size. If the area of the part is under a certain dimension, let's say a square foot, then the tabs or skin will not be cut on the second pass. So on really small parts, you might have a 32nd of an inch skin there. Don't cut, this says don't cut them out. I'll just bend it off because 32nd of an inch is not much at all. That's what that does. This one right here, if the area of a part is above, this is a two-part deal here. If the area of a part is above a certain square footage, it's above that square footage, so these are bigger parts, you might say, and both dimensions are greater than 7, then the tabs or skin will be cut out on the first pass. The reason it says both dimensions is because you can have, let's say, a stretcher that's 3 inches wide and 9 or 15 inches long, and that's really a small part. And that could be thrown across. So we want both edges or both dimensions, that 3 inches and the width and the length, to be at least a certain dimension. And if they are, then they will be cut out. If they are not, if they don't meet this rule, this dual rule, I might add, then they will not be cut out on the first pass. So we have some smaller parts that are not cut out. If you have a situation where you want smaller parts cut out, but they're not, check this area. And this is probably the area which needs adjustment. Any quick questions?
And we're over time now, so.
Okay. All right. Tom Finnegan, I will be looking at your tech support issue about the edge banding shortly.
Tom left because he doesn't have the CNC.
I'm sorry, say again?
Tom left because he doesn't have the CNC,
Oh, okay, never mind.
but he did send the ticket.
Okay. All right. So I will see you guys next month. And Thomas, I'll be calling you shortly.
Frank, he just had, Thomas just had a guy pull into the shop, so if you give him about 20, 30 minutes, that'd be better.
Okay, would you ask him to give me a call when it's convenient for him?
Okay, even better. That's great.
Okay, very good. All right, we'll talk to you
Thank
guys
you.
later.
Thanks. Bye.
Yeah.
Bye-bye.
Okay.